Hi guys, greetings from Bulgaria. This will be the first module from a new series dedicated to creating a comprehensive test automation framework. Before we begin, hit the ring bell so that you get notified about any new videos published on the 𝐼𝐴𝒐𝒏 YouTube channel each week. Also, check the 𝐼𝐴𝒐𝒏 blog because there are many advanced test automation tutorials to help you become a much better test automation engineer. Let's quickly review what we will cover in the upcoming modules. This is just a group. Each group will contain multiple videos. First, in this particular module, we'll start with pinpointing precisely what we aim to achieve with our framework, exploring open source tools for inspiration, and setting a solid foundation for innovation and effectiveness. Create a list of requirements, parts we want to include, and features. Then, in the sequential modules, we will start with creating a web project containing core components and services for web automation. Then we'll proceed with mobile test automation module and API project where we will use some web APIs for test data management and performance checking. Also, after that, in the complex component mastery group, we will create some more advanced web components for handling, for example, data grids or modules such as online editing like Word. Also, we will integrate some third-party integrations for email, SMS testing, handling two-factor authentication captchas, of course, integrating into the Lambda test cloud. After that, we will proceed with configuration management for handling different test environments, implementing logging, supporting responsive testing. After that, we will handle and improve our test automation framework to integrate more features like bidirectional APIs, CDP. We'll integrate some reporting solutions, handle some like security best practices, like key vaults and others. And we'll focus after that on execution and scalability. But more about that later. Now, in this particular module, we'll begin by talking about what is the problem that we try to solve. We'll discuss some steps and phases during this initial assessment and evaluation of different solutions. And we'll decide later, I will give you some hints how to decide whether you want to pick an existing test automation framework or to create your own. Of course, the whole course is about teaching you how to create your own. So we'll create at the end a development plan based on the requirements that we developed and picked, and using the assessment criteria that we defined. So let's get started. What is the problem that we try to solve? Many companies at some point decide to start automating their QA activities and regression tests. And for some new projects, or whether you want to establish a test automation from the start or later. So these companies, they have to pick the right tool or solution for doing that. And we're going to discuss this approach for selecting the tools to evaluate, compare them, and decide which is best, maybe. And in the end, you will know whether to pick an existing test automation framework or whether to create your own. The first phase is first you need to create a list of requirements that you want to achieve. For example, automate the login page, create new accounts, submit tickets, create new purchases, run the test nightly, etc. And how to do that, you can brainstorm with your team. Maybe you can ask another division for if they have a very strong QA architect, to borrow the architect for a week or two to help you with this particular research. Maybe you can find and hire for a while a consultant or consulting agency, and maybe you can do stakeholder interviews. Just remember that stakeholders such as business owners, they often don't have the technical expertise or understand completely the testing process, but you can ask them, interview them, so that you can find what is important for the business to define those requirements. Now, during the second phase, we need to research existing solutions. There are many of them. I will, in a minute, we will review and I'm going to show you how to do that. But maybe we need first, in order to be able to filter all of the different solutions, because there are so many of them, we want to pick just 3 up to 5. So we need to define the so-called hard requirements that in a minute we will discuss, and ignore for now the nice to have stuff, right? So based on these hard requirements, we'll filter among the tens of thousands of the hundreds of solutions out there to pick just a few, these 3 up to 5 more serious candidates. And this will be the solutions that we'll further use for creating the proof of concept and later to assess. So first we need to define those hard requirements. You can ask for some recommendations in user groups or in LinkedIn, or if you have some kind of meetings in your country or town, or you can just search. I'm going to show you another way because our framework will be based on WebDriver, so they have a good list with official frameworks that are part of the ecosystem. Now, some hard requirements, at least for me, that I usually use, because many of the enterprise projects that I'm part of, they have a web interface, they have a mobile interface, so we need to be able to automate both. It needs to be an open source solution. We don't want to pay licenses. This doesn't mean that it will come for free, as we'll discuss later. We want a community support. We want to have very good documentation and tutorials if we pick an existing framework, so that we can learn how to use it. And we want frequent updates to support latest devices, browsers, handle some security flaws, etc. These are our hard requirements. And later we need to define some, the next phase is to define some criteria which you use to compare the solutions. Since all of them are more or less subjective, we will provide later a rating from 1 to 5 for each of them. Again, a little bit later I will show you an example, but let's first discuss them, right? And again, this is just an example. You can put whatever you believe is important for you. For me, usually it's the solution to be a programmatic one, not to use some kind of a no-code solution, right? But it will be up to you generally. So some of my assessment criteria are again to be able to automate web, maybe with WebDriver, but it might be Playwright if you choose. Maybe automate mobile, again, my preference is to use Appium underneath, to have a good documentation, maybe to be really easy to create new tests and to start very fast. Again, this is a little bit subjective, and it will be depending on maybe the coding skills of the different team members. This is why, as we'll discuss later, it will be good to integrate more people into the process of evaluating the different solutions from different seniority of your team. Testability, most of the frameworks that we're going to pick to research offer such capabilities, like internal weights, etc. For me, really important is this failure troubleshooting analysis, because after you create the tests day to day, when the tests are executed, it should be relatively easy for you to understand whether when the test failed, to understand whether there is a product bug, problem in the test environment, in the test data, etc. Also test readability. Again, this is a little bit subjective. As you'll see, some frameworks that we're going to discuss use font interface. For me, this is not so readable, but many people prefer it. Again, this is a matter of choice and preference. This is why, again, more people should be included, not just the QA architect or QA lead. Quality execution support, like executing the tests in platforms such as Lambda test, easy integration in your existing continuous integration tools. Reporting tool support, most of the tools, whether they use the standard tools usually, like Allure or Report Portal, or the reporting tools of their continuous integration systems, but still some solutions, they offer their own reporting, and this is important for you. Also, for me, in order this to be a real framework, it should allow you to customize it and extend it, and it really depends on how much time is needed to understand how to do it. Some of the frameworks that we are going to research lack of documentation about these more advanced capabilities, even if they offer it, or just provide, I don't know, a GitHub example without much explanation. For me, another important thing, no matter whether this is mobile or web, is to be relatively easy to support multiple environments through some, for example, JSON configuration files, to support responsive testing, secrets management, very important, this security stuff. Specific tools integrations, I guess some frameworks come with pre-written integrations instead of allowing us to write new ones. And maybe one of the most important criteria is to have different options. For example, if your application and your development team is using .NET or C#, probably the framework itself should be written in C#, and you need to use the same technology stack, or Java or JavaScript. It will depend on your team or company. Now, before we proceed with the phase 4, implementing the proof of concept, I want to show you how we need to do this initial type of research of existing solutions, how I usually do that. For me, the easiest way, especially if you pick WebDriver for the web part, is to open Selenium website, and when you go to About, there is a link to the ecosystem. Under the ecosystem page, you can find the different drivers, the different bindings, and there is a section about most of the available frameworks out there. As you can see, even you can see my name with the 𝑨𝒏𝒕𝒐𝒏 framework. It won't be fair to use it in this type of evaluation assessment, so I will skip it. I will use some other frameworks, like for example Atata framework, Selenite. Maybe we can see some examples from this Shaft engine. I found it really interesting. So I opened Atata. This is one of the popular C# frameworks beyond 𝑨𝒏𝒕𝒐𝒏. It's really cool. I use it. It was created before 𝑨𝒏𝒕𝒐𝒏. For me, it's relatively complex at places. I always start with looking into the getting started section, even if you don't use the framework directly, and at the end, if you decide to create your own framework, this type of research is very important, because you can all of these solutions, they are open source. This means that you can pick some parts of them and integrate them in your own thing. Usually I'm against reinventing the wheel and every time writing your own thing if something very good exists, but it really depends on the context. When I was writing initially 𝑨𝒏𝒕𝒐𝒏, I researched all of the frameworks out there, no matter the programming language, and I picked the best part of them and rewrote in a way some of their features. So Another thing that you need to consider is how you are going to use the framework. For example, this particular framework, it's used via NuGet packages. My preferred way, and we will include that into our high-level development plan, is that I prefer to use the framework as a Git submodule. Maybe in the next video I'm going to explain that in more details, but this means that you're going to create your own repo and use the framework as a subrepo of your own. And this means that all of customizations, etc., will be out of the original framework repo. And this way it will be easier for you later to pull the latest changes and updates from the framework, right? If you use NuGet packages, it's really tricky when you want to debug the framework, and this is why this is important. Instead of just cloning the repo and directly creating a new project inside the solution of the framework itself, it will be really hard for you later to create pull requests or to do some updates. So another thing is that Atata, for example, they have an installation plugin, I think, and they provide some templates, which is cool. Another thing that it's important about Atata, as I said, we use it as a NuGet package. They heavily use some generics. For example, this page object here. Let me zoom a little bit. For me, this is a little bit trickier. This type of syntax with generics and underscores, I don't get it. For me, it's a little bit harder than it should be. But another good thing about this framework is that it gives you different web components for the different elements, similar to 𝑣𝒏𝒕𝒐𝒏. Instead of having just like Selenite, they have Selenite element, like iWeb element in WebDriver. And usually I prefer this approach because it makes our test more readable later and gives just the specific properties or methods. For example, instead of having just a generic method like send keys, you have here a method set password, or here set text, etc. Or it doesn't make sense to click in the password, but instead you have just click for the button, right? Another thing is that this framework is using fluent interface. Again, it's a matter of choice. For me, it's a little bit more verbose and harder to use. Again, I'm not completely against fluent interface, but as you can see right here, just let me zoom out here. This is the fluent interface. This is just a single line, right? And you need to, using enter, you need to move it to the next line. You cannot use, for example, Visual Studio formatting feature. I don't know. It's a matter of choice. Many people prefer it. There are many popular assertion libraries that are using this syntax. It's fine. So little by little you can go through the documentation and see all of the examples. This framework, it has a very nice documentation, which is very good, which is very rare for a framework. And it has a lot of demos and tutorials and blog posts, which is good. They have their own here syntax for assertions and aggregate assert, which is awesome. Again, it in some places it's a little bit more verbose and hard to understand how to use it. They have many examples and different packages for example, Kendo components, Bootstrap components, etc. I will skip 𝑣𝒏𝒕𝒐𝒏, as I said, but you can check it. There is a very nice documentation and examples. The second framework that I want to show you is Selenite. It's a framework in Java. No matter whether you pick, for example, another language besides Java, it's good to check, for example, C# and Java, maybe JavaScript. It depends whether you understand it. Here are some tutorials. You can use it as a Maven dependency and directly start using it. From the little time that I use it, it's much more lightweight. It's completely the opposite of a Tata. You use syntax similar to jQuery in JavaScript with this dollar sign to find the elements, and as you can see, you don't need this. You don't need every time to provide this by some locator, right? And you have these built-in weights, which is good, a good thing. They have some nice tutorials. My personal opinion is that their documentation is, as you can see, it's not so good as a Tata. It's not so detailed. They have, since this framework has been developed a long time ago, it's still maintained, and there are many examples and many articles, which is fine, but it lacks some features that more advanced frameworks have. Still, it has some examples again on GitHub as well. Also, they have, for example, a plugin for APM for mobile testing. I can say that it's a little bit more verbose how you can set it up instead of using configuration. Maybe they have, I don't know, but here in the example, from what I see, you need to define it as a regular RPM test, so I'm not sure the complete benefit of the framework. Maybe you can still use, as you can see, this dollar sign, etc., and the tapping and everything. It's not my thing, but many people prefer this framework because it's lightweight, which is good. And lastly, the Shaft framework. Again, it's maybe not really my thing, but it supports both not only web but also mobile and desktop. So here is the syntax. This is regular WebDriver code, and here is the Shaft code. There are some additional methods, a different syntax. It's a mix between Fluent and a regular code. I don't know, when I check it, I don't see the benefit for me. It's messy, it's long. You need to define here the as private fields the locators and then paste them inside the action types, which makes the writing of the tests more complex for me and more verbose. Again, there are many examples here in their GitHub repo. Again, I don't see much benefit of having such a syntax, but still, I haven't used it really in many projects. I just checked the documentation. Again, it's a matter of preference, I guess. All right, you saw my explanations when I was doing this type of research. Of course, you need to do it more truly and pick more solutions, right? And as I said, during this implementing proof of concept, it's important to form a working group. It will be best if it's built from technical experts like test automation engineers, maybe seniors, but not only, because juniors will need to write tests as well. You need to implement 2-3 tests for each solution. Maybe everyone from this group by themselves needs to write these 2-3 tests to feel how to work with the framework. After that, the step 5 is to rate based on the assessment criteria, to provide a rating for each of the assessment criteria that we defined at the beginning. You can further extend the rating phase by prioritizing the different criteria and provide weight index for them. So put rating between 1 and 5. 5 is the highest score, and if there is a weight index, you will need to multiply it by it. For example, 1.5 for good documentation. This means that if I put a rating 4 here, and if I have a weight index of 1.5, I will multiply 1.5 by 4, which will make the actual rating 6. That's it. And everyone from this working group will need to create such a table. And we'll need to create an average. After that, during the phase 6, each person from the working group again should provide their ratings based on the proof of concept. Then you can also put the weight index again based on the participant seniority, authority, or role. In the example on the first row here, participant 1 is the QA lead, which is why we multiply all scores by 4. And here you can accept that participant 2 is like a principal, right? And this is why we multiply by 2. And then you have your average from all participants for all of the frameworks. After that, the phase 7 is to create a high-level test automation strategy if you don't have one already. We need to have a list of test cases, no matter whether they're detailed or abstract, that we'll need to automate. Then we need to have priorities and categories by them, and so we need to put these test cases in 3 phases. Maybe we'll start with the phase 1, which are the highest priority. At least this is my way. And then, based on the test cases that we need to automate, we can update our test automation requirements, right? That we defined before. This is why I included this phase here. And then we need to provide estimates for phase 1 test cases. Why this is important? It's important because if you decide to create your own framework, sometimes it can take months to develop it, depending on how much people were involved in this effort and about their skills, right? And if it's very important for the company to have this regression test in, I don't know, 4 months, and if you need 3 months to develop the framework, then the choice is obvious that probably you will need to use an existing test automation solution. But again, it will depend on your particular context. And again, for all of the requirements, maybe you don't need to develop all of the features at once, but maybe you can do them in stages. Now, the final decision, existing solution or not. You will need to answer some of the questions, like how much time you will need to implement and even create the customizations, even if you pick an existing solution. How much it will cost to maintain and support it later. Do you have an easy way to learn it? Are there any trainings, etc.? Or if you make the final decision to develop your own framework, what are the estimated development costs and time? For example, if you need 3 months QA architect time, this means that the cost is you need to multiply its salary by 3 to find the real cost, compared to, for example, paying just the licensing cost for something, even if you pick a paid solution. But this is just the upfront cost. What resources are needed upfront? Do we have the necessary expertise and skilled personnel? Maybe if you don't have an architect or a senior people, maybe it's not a good thing to develop your own framework because maybe you won't be able to do it. Is it adequate training and support available for the team if we want to upskill the team so that they are capable of writing a framework? What are the long-term support and maintenance costs? For example, if you need your architect, if it needs 1 week per month, then again, you know the cost. Can the team handle ongoing updates and scalability issues? How well will it integrate within your current technology stack and continuous integration, continuous development tools? Can we ensure the required performance and scalability? Can we provide comprehensive documentation and user support? Will the framework be actively maintained and updated? Can it adapt to future technology changes? So many questions, right? But again, let's assume that based on your initial research and requirements, let's decide that we're going to create our own framework. I'm going to teach you how to do that. So we need a high-level development plan, right? So based on everything that we discussed right now, let's use .NET as the primary framework. We're going to use C#. Probably if you're a fan of Lambda tests, you already watched some of my videos about design patterns, part of the Lambda Test YouTube channel. I will include a link below. So we're going to implement some design patterns for maintainability. We're going to use WebDriver, APM for mobile, and REST for the API. We're going to support both MS-DES and NUnit, no matter that I'm more of a NUnit fan, because it will depend on the different teams in your company which of these unit testing frameworks they will want to use. And then again, we will need to decide how to use the framework. As I said, I'm going to teach you how to use the framework, not as NuGet packages, but this more maintainable way as a Git submodule. After that, we'll create separate projects. This will we'll start in the next module with creating a project for web, then we'll proceed with mobile and API. We'll create a project for shared core logic. We'll create a dedicated project for our tests, and we'll have one more project for all of the different integrations, like integrating with Lambda tests, Mailswap, Twilio, and other third-party services. So, in this first module, we started with pinpointing precisely what we aim to achieve with our framework, exploring open source tools for inspiration, created a list of requirements and criteria to evaluate different solutions. We discussed the different phases for this process of evaluation and research, asked some questions to finally decide whether we want to use an existing test automation framework or create our own. The decision was to create our own framework, so we ended up with a high-level development plan that we'll use in the next modules to build our own test automation framework, step by step. And in the next module from the series, we will continue with the first brick from our future framework, creating our web core project. Thank you for watching. If you have any comments, put them in the comment section below. Also, don't forget to check the Lambda Test blog for many awesome test automation articles to learn some new tricks. And don't forget to get your free certification about many test automation technologies on the Lambda Test certifications program. Thank you, and see you in the next module.